Hey, what's up, guys? This is Scott Lester with SL Drafting Design. Thought I would make another quick video today. It's been a couple of years, I think, about 2 years since I had a blog, article, YouTube video, or anything. So I wanted to make this. Had a little bit of spare time, and I thought I would make this to help you guys out. I'm starting to notice that I'm getting more and more solid edge questions since I feature a lot of that on my website through my blog and stuff. A lot of views on some of my how-to articles, so that kind of inspired me to make another video, and hopefully, I said I can stop letting life get in the way and make a few more. So I want to get into this. Today's video is going to be about how to use inner part copy. I've got started the blog article, and you've probably found this link via that. So what is inner part copy? Let me actually close this down. This is a personal project I'm working on. So inner part copy is, as the blog mentions, a way to use top-down modeling technique to in place or in context place parts without using mates. So you're designing them where they sit in space in an assembly. So to do that, I wanted to just very quickly create a common assembly or a design that I have to do quite a bit for some of my customers. So I'm going to get into it. I'm in Solid Edge 2022. I'm using Foundation. So most of all the features I have, as long as you've got the very minimum, which is Foundation, you should be able to do this. I'm going to start with a new a new assembly, and I'm going to go with an inch. And as I mentioned in the blog, there are a few requirements in order to use in context or inner part copy. So to do this, you need to have at least one part in your assembly, and you need to have your assembly saved, or usually it'll pop up a little warning message that you need to have it saved. So what I want to do is design some sheet metal parts around a tube frame. So very quickly I will draw a sketch and start creating the stick stick frame for using frame parts here in the assembly. So I'm going to say it's going to be let's go with 6 foot by 3 foot. All right, close. All right, and then so that's just a normal sketch. I'm going to go to 3D sketch and draw some lines. So let's say these are 4 foot tall. All right, and then another line, and another line. And I wanted to start this from scratch instead of just having something ready, so you can really see the top-down approach. All right, and then let's put a dimension on one. I've made all those equals, and I want to do again 4 feet. All right, another line. Sometimes 3D sketch really doesn't work the way that I want it to. So here's what I'll do. I'll just do another sketch, normal 2D sketch on a parallel plane. Rectangle from there to there. All right. Finish. All right. Then I'm going to go to my tools, frame, and we'll go with we'll click frame here. Wow, it's been a minute since I've had to do this. And click, yes, I do want miter joints. Click OK. And I want to go to the bottom. And we're going to go with, what tubing do I have available? Let's see. Wrong folder. Let's see, square tubing. Let's go with a 2x2x8. All right. Accept. All right, and I want these to go to the inside. All right. Okay, and here, 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 and here. Same thing. I want them to go to the inside of the profile. All right. Okay. That one placed the way I wanted it to. That one's good. And you see it's automatically trimming everything the way that I would want it to. Alright, so there I have my base part, and I'm going to close out of this frame. And a lot of times for particular customers, I have a frame, like I said, with a sheet metal facade. Traditional bottom down or bottom up approach would be, I would need, I made this, I believe it was, let's look. That first sketch was 72 inches long. So, and I made this 4 foot tall. So 48 by 72 would be how big this panel is. But as we know, and we would just open up a sheet metal part and make it 72 inches by 48 inch thick sheet metal panel, and then we would mate it to a side. And that is the traditional bottom up approach. But as the purpose of this video is, this is a top down approach using inner part copy. So now that I have this, I'm going to save it, and we will just go to, let's see, SLD. I can't remember exactly where I put it, so we'll just go to, we'll go to my desktop, we'll create a new folder, and frame example. All right, and we will put frame, put tube frame, and hit save. All right, now in order to do this, I need a new part. I could easily just say, go to the application button, new, and start a new part. But to use inner part copy, it would much be easier to use our create part in place. So I'm going to click that button. It's going to give me some options. I want to ground the components because, again, we're not using mates to place this. I want it coincident with the origin assembly. So whatever, when I design this part, its origin and its main planes are going to be what they are of this assembly there. So they won't be in like the middle of the part or anything like that. And create component, then edit in place, or create component and stay in assembly. So I can, if I click this button and I click OK now, it's going to ask me which template do I want to use, and once I accept that, I will stay here. But what I actually want to do is say create component and then edit in place. I'm going to click OK. And again, it's going to ask me for what template I want to use. And actually some of these options, like the grounding option is here that we just seen. I'm going to use the ANSI inch sheet metal that I already have. And again, just make sure your options match these, and I'm going to click accept. All right, and then it's going to prompt me to save my part. So we're going to call this the front facade. Maybe I've spelled that wrong or correct. All right, so save. All right, and now you can see, because the frame has went into this more translucent, transparent type view, we know that we are in context editing, and we can also see a close and return up here. There's a little feature or a shortcut button where we can hold Control Q, and it will toggle that on and off. And I can show you when we get more parts in here. It's actually very helpful. So now you'll notice that inner part copy is found up here. Right. So in order to do that, you'll click it, because I want to create a piece of sheet metal that will go right here, and I want it to be the same size as my overall frame here. So I'm going to click inner part copy, and you'll notice that I can actually select parts here. So I want to select that, and by default it automatically goes to this face. Because I have rounded edges, I don't want to choose face, because what I'll end up with is a sheet metal part that's too small. So I'm going to drop this down, and you see you've got face, body, chain, feature. I'm going to choose the body feature, select that, and either right click to accept or the green checkbox. Right, and then you can see once you have an inner part copy over here, I'm using the ordered environment, and you can see that I have an inner part copy. All right, and it shows up as a purple surface, and that's all it is. It's not geometry here. And I just mentioned earlier about the little shortcut menu. If you hold Control Q again, now you can see that it's as if I'm in the part, not in context editing. So that way I can't accidentally grab like other features. So again, I can toggle that on with Control Q very quickly. But I need more, because I need the overall size. So I'm going to grab another inner part copy. I want that right one. I want the body. I want that one. I want the body. And again, I'm just right clicking to accept. And then one last one, inner part copy. I want the body. All right. Now, this is where I would like to hit the Control Q, and I'm going to do a tab, and I want it on that surface. So this is where we get our first linking of parts. I'm in context editing, so this part, this part, this part, and this tube, they all exist in another file. And these purple surfaces are references of those of where they sit in space. So once I click this, if this surface ever, like if you were to go in and delete this particular frame component, then you will end up with a broken link. Now, if you just edit the profile or something like that, then you may not end up with a broken link. But or if you just move it, like if we change the size, which I'll show you here later in the video, then you may not end up with a broken link. But as long as your geometry is not changing, you will be fine. So I'm going to choose that. And then here's where we place our other links to these parts. So again, you can see if you're not using proper design intent, as I mentioned in the blog, then you can end up with undesirable results. So you need to, like I said, have very disciplined design intent and understand how your parts are going to change. So I'm going to do a corner rectangle by 2 points, and I'm going to just kind of draw it outside, and I'm going to use some constraints here, sketch constraints. I want that to be collinear with that edge, that one with that edge. And again, it seems like this may be slower than just using bottom up and mates, but I'm slowing it way down. I can usually work much faster than this. And also it helps with changes very quickly. So you can see now that my sketch is black. Depending if you have your relationship colors turned on or not, yours may not turn black. Mine do. And I'm going to hit close on that, and then I want to go to the outside. All right, hit finish, and here I will go ahead and say I want a 304 stainless, and I want to make this a 14 gauge. So go to my gauge properties, change that to 4. Nope, not 16, 14. click apply to model. All right, now you can see I've got a facade. So if I hit close and return now, I'm no longer editing in place. I'm simply in the assembly. Let me turn some sketches off here. Let's turn that one off. Oop, went too far. Turn that part back on. Now you see that I've created a facade, front facade, that is the exact length and height of my frame. So again, I could have done the same thing by saying I want a 72-inch by 48-inch piece of sheet metal, 14 gauge, placing and mating it. Now here's the strength, and it works just fine, but here's the strength of your top-down design approach using inner part copy. If I save this now, and I go to my sketch here, this sketch is the driving of how long and wide this frame is. So if I edit this sketch, and let's say I change this to 60 inches, hit close, hit finish, you see everything updated, and now my facade is now 60 inches long. So very quickly I changed one dimension, and it affected the frame dimensions, and it affected the facade dimensions. So in just a very short amount of time, I was able to make a very quick change. So that is like the what I would consider the most valuable contribution for using an inner part copy. I got it exactly in space where I wanted it. It resizes when I change the features that I've related it to. Now again, what you could run into is, let's say I've had this happen. I've used 2-inch by 2-inch framing. Let's say that customer comes back to me and says, we really want to use some 1-inch by 1-inch. We need it lighter. And that's where we could run into an issue where we've changed the geometry of, even though it's it's a square tube, but it's technically a different square tube. If I go change this, then when I open this part, I'm not going to do it just for the right now. I will here later in the video. But if I go change this part, which, as you know, we used the face as a plane and we use the edge as a coincident sketchmate, then we may end up with errors over here, on our tab, saying that geometry has been lost. So again, we need to be able to have good design intent approach, knowing that that's how this part is made, so that I know that if I change the length of this, that it will update. But if I change geometry totally, that I may end up with some broken links. So just keep that in mind. Let's create another part. I'm actually going to open this. All right, and I want to do a cutout real quick. So we'll just do a normal cutout on that surface, and I want it to be, let's see, you'll have to excuse me, I also use SolidWorks on my daily work job, and when I come in and do videos like this, I'm in Solid Edge, so sometimes I have to remember which one I'm working in. All right, and then here, I don't want that to be, all right. Let's say we have an access door that is 24, and we'll go 23 by 23 hole, right, with an inch overlap. Just going to be held on some by screws or whatnot. All right, hit finish. All right, we can save that, we can exit it. Now we're going to create a panel that will go on the face of that using inner part copy. All right, so here we go. We will go again to create part in place. Click OK. Yes, I do want ANSI sheet metal, and we're going to call this access door. Right. And the reason it disappeared is because I had Control Q toggled off. So that's how you do that again. All right, over here, drop down, inner part copy, choose that, and I'm going to do body again. I don't like to use face. That's just a personal preference. In this instance, I could have used face. I don't have any rounded edges, so but again, I'm just going to use body. All right, right click. Now I'm good. I will Control Q, and I will make a tab on that face. And my design intent, again, as I wanted a 1-inch overhang, so 1 inch, 1 inch. Let's do this different, so we don't have to have so many dimensions. We will also draw another line from here to here. We will make it a construction line. Solid Edge wants to do it. All right, from the center. And because we've used the center of both, we only need 2 dimensions. All right. There. So now I have my 1-inch overhang for an access panel. We want it to the outside. Hit finish. All right. Now I will close. So now you can see that I have that panel. I'm going to open the part now instead of in context. And again, that's the cool thing about this. Once you get the part, you don't have to always stay in context. I've just opened it normally, and I want to do a 304 on that as well with a 14 gauge thickness. All right, exit. All right, so now I have my access panel. Of course, it's got to be held on by something. So I will right click, edit the part in context again. So now you can see that I'm in context. You can see the little red X there. And I need some screw holes. So we're going to go with a hole. We want to go with let's go and do the options here. Let's say we use a number. Now let's go with a quarter. Quarter may be a bit overkill. Let's use number 10. A number 10 hole, normal fit, just a through hole. Click OK. And I'm going to change my view to have to where I can see the back, the hole back here, and the light gray represents the hole in the back. All right. Same thing, and make sure my. All right. We're going to go with a sketch. Oh, I've somehow exited my hole command here. Coincident. Quarter through all. General screw clearance. There we go. Okay. All right, let's go with a line here and here. Actually, I don't want to do that either. We know that it's an inch overhang, so I don't want to do that. Let's see. Yeah, let's go back and do that. All right, and we're going to go in here. And what we can do is, that's an inch, and I want that to be equal, I think it'll do this, to that divided by 2. Yep. All right, so my design intent was I always want, for this little construction line, I'm going to use this to place my holes. That way I always have my holes in the middle of these 2 items here. So I should have, oh, got to do it again, this direction. Let's try that again. That and that. There. Make this equal to that divided by 2. Alright, so that's in the middle. And then I should have this way. So I need this and that. And I want this equal to that. Right. I'm going to change it to a that, and then go back to my whole circle here. So I want one in the corners. Again, to do this, you need to have some working knowledge of Solid Edge. This is more advanced features. And I think for the purpose of this demonstration that 1, 2, 3, 4, 5, 6, 7, 8 screws is enough. If we wanted to go further, we could put some in the midpoints here. But I think for the demonstration, this will be fine. All right, so now I have my holes. And I would go back to a, there you can see I've got the screw holes. All right, hit close. And of course, we'll probably use like some self-tapping, so we'd have through holes here and let them screw into that, which may be difficult. We may not want to use self-tapping. Yeah, we'll have to though. Better make that mild steel instead of 304. We'll never drill into it. But anyways, so there we have that. And again, we were able to use references from the part here so that, again, if this ever changes, so if I open this part and that hole there, let's say I make it 26, gotta accept it, by 26. Because I've used good design intent, and sometimes you've got to go to tools when it doesn't update and go to update active level. Right. And now you can see that my panel resized and my holes are exactly where I need them to be, right in the middle of this 1 inch. So again, that is how you use inner part copy to do this. Again, but I'm creating links between parts, so but it does make things a whole lot easier. So again, if I wanted to do it over here, we will go to create part in place. Yes, accept, and we're going to call this the right facade. All right, Control Q, tab up, sorry, inner part copy. I get a little ahead of myself sometimes. So body, 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 and body. All right, hit Control Q, and then I want to do a tab here. Same thing, go with a 2-point rectangle, coincident, and I did use Control Q to hide other items that I don't want to accidentally lock on to. I'm just using a coincident or collinear mate here to put these edges exactly where I want them. Hit close. I'm going to go to the outside, hit finish, material 304, go with a material table 14 gauge. All right, hit close. Now I've got my right facade on there. And then you can see how my edges come together. A lot of times when I have something like this, I will go with a little corner treatment. So create part in place, and ANSI inch sheet metal, and we'll say corner treatment. Okay, Control Q, and I need inner part copy. I want that body. I want that body. All right, and I need one more because of the way I want to design this. I need body here and body there. So two more. All right, Control Q to hide everything, and I want to do a actually, I can choose the planes. So we'll just delete those. I want to do a contour flange on that plane there. And I need it at this corner. So that way and that way. Let's make those equal. Let's go with a 1 inch. And we will go collinear to that edge, collinear to that edge. Accept it, push it to the outside, and I'm going to use another reference. Finish. That way if the height of that panel ever changes, it also changes this, the height of my corner treatment. All right, and let me save this, and the only thing I forgot to do was go to my material table, and we'll make this out of 14 gauge as well. Apply. All right. 304. So now you can see I've got a nice corner treatment to hide that if I don't want to like weld it all the way down. You put screws, make things removable easily to disassemble. And again, we can go add screw holes and everything in there if we wanted to. But again, let's go back to my frame, because that's kind of the driving feature. I go to not that one, that one. Let's see, where do I have that? I think it's just under my 3D sketch. So my 3D sketch, edit that. Let's change that to 60. Go back to tools, update, and you can see everything goes with it. Why did this not go with it? We'll find out. Let's open it and find out. Should have. Let's see, inner part manager, update all. Like I said, sometimes a solid edge is a little finicky. Whenever you've made a change, and me knowing my design intent, I mentioned it in the blog article, you should have a full understanding of how the model is going to behave. And I was fully expecting this to grow in height along with everything else because I told it to. I linked this when I did the extrude. I linked it to that corner right there, so it should have went up. Anytime that you're using inner part copy and a top-down approach and it doesn't behave like you want, first thing you need to do is open it. All right, double check it. It looks fine in here. Make sure both of these links are good. Make sure there's no arrow or error on your, everything looks fine in here. So I exited back out. And the next step is to go to your tools and go to update active level. If it still doesn't do it, go to your inner part copy. This is inner part manager. Inner part manager shows you can see it lists your inner part copy. So front facade has an inner part copy, and it's a child of the square tubing. Whereas my access floor panel is a child of the front facade. So here you can see in list form what my parent-child relationships are in each part file. Again, the front, access door we used, it is a child of the front facade. So if I change the front facade, it changes the access panel door. But if you're having issues, something's not updating, update active level or inner part manager and click update all. If it still doesn't do it, sometimes you can hit component tracker and hit save all. So one of these three buttons here under your tools in the assembly will a lot of times force the update. So again, don't panic too much. Just go through the steps to see why it's not updating when you know that it should. Again, these are advanced features. If you're new to Solid Edge, you maybe have not been able to keep up, or you don't quite understand exactly how I'm doing it. But if you have any questions, just let me know. I'm not going to continue to do around it. I think using these two forms is handy. Now, like I said, if you have any questions, please reach out to me in the comments, or you can send me an email. and I'll be glad to hear from you. Again, thank you for watching this video today.